All right, today we're going to be in the probability and stats notes packet, and we're going to be starting it with the fundamental counting principle. So on page 1 of your packet, your page should look like this, and first we're going to define the fundamental counting principle. So if decision M can be made, M ways, and N can be made N ways, then the two decisions can be made M times N ways. So basically you take the number of ways the first event can happen, then the number of ways the second event can happen, and you multiply those two numbers together. So let's look at some examples. The ice cream shop offers 3 cone sizes, 15 flavors, and 8 toppings. How many cones are possible if you can only choose 1 flavor and 1 topping? All right, so there's 3 cone sizes, 15 flavors, and 8 toppings. So I'm going to multiply those 3 numbers together, and that's going to give me my total possible outcomes. So when I get that, it gives me 360. All right, Virginia's license plates consist of 3 letters followed by 4 digits. How many different license plates are possible? All right, so 3 letters. So in the alphabet, there's 26 letters. So for the first letter, there's 26 options. The second letter, there's 26 options. And the third letter, there's 26 options. And then it's followed by 4 digits. So we're thinking of single digits. So that would be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's a total of 10 digits. So I'll have 10 times 10 times 10 times 10. All right, then you're going to type all of that into your calculator, and it's going to give you 175,760,000. All right, number 3, Nick's science class has a section with 12 true-false questions. How many different ways can he answer these questions? All right, so on the first question, there's 2 different options, true or false. The second question, there's 2 options, true or false. Third question, fourth question, fifth question, so on and so forth. All right, another way of writing that would be 2 to the 12th power, because there's 2 outcomes for all 12 questions. So I'm going to type that into my calculator, and it's going to give me 4,096. All right, number 4. To enter their home, the Clayton family enters a 4-digit code. How many codes are possible? All right, so kind of like we were talking about up here, there's 10 single digits. So for the first digit in our code, there's 10 options. The second one, the third one, and the fourth one. So we could also write that one 10 to the 4th power. And when I type that in, that gives me 10,000. All right, the next thing we're going to talk about is factorial. So a factorial is a number with an exclamation point after it. And it's the product of all natural numbers from n to 1. Natural numbers being non-negative, non-decimal, just your basic whole numbers. But we can't say whole numbers because then we would have to include 0, and we can't include 0. So that's why we say natural numbers. All right, so some examples. 9 factorial. So that would be the same thing as saying 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay? And so when I type all that in, that gives me 362,880. All right, then I'm going to do 12 factorial in my calculator. And it's going to give me this big old number. 479,001,600. Then 8 factorial. Then the fraction, 17 factorial over 11 factorial. $8,910,720. And then the last one, 0 factorial, just gives you 1. All right, and next we're going to talk about permutation. So it's NPR. An arrangement or lineup of objects in which order matters. All right, then we have our formula. All right, but the calculators that y'all have will actually do this for you. All right, so on the Schoology post for this lesson, I have attached some YouTube videos to show you how to type these permutations in your calculator without using the formula. Just a really simple, easy way. So make sure you watch that so you're able to know how to type it in. All right, so number 5. How many ways can you arrange the letters in the word dinosaur? All right, so N stands for your total number of objects available. So N is going to be my total number of letters in dinosaur. 3, 4, 5, 6, 7, 8, and there's 8. All right, and we want to arrange the letters dinosaur. So R stands for the number of objects being used for the arrangement. So we're using all the letters. So my R value is also going to be 8. So I would type in my calculator 8P8. And when I do that, that's going to give me 40,320. All right, number 6. 7 students are competing in a geography bee. How many ways can they finish in first, second, and third place? So N is my total number of students, which is 7. And R is how many I'm using for the arrangement. So they want to find a first place, second place, and third place. So that's 3 people. So then it's going to be 7P3 in my calculator, which is going to end up giving me 210. All right, let's look at the back. All right, Melanie is taking 4 classes this semester: American History, Algebra 2, AP English, and Chemistry. How many ways can these 4 classes be arranged on her schedule? All right, so we need our total number. So there's 4 total classes, and we're arranging them, so we're going to be using all 4. So 4P4, which gives me 24. All right, number 8. There are 16 players on the baseball team. How many ways can the coach make a 9-player batting order? So N is my total number of players, so there's a total of 16 players on the baseball team. And out of those 16, the coach has to pick 9. So it's going to be 16 to 9 in my calculator. Which gives me a really big number. I'm not even going to try and say that number out loud. All right, number 9, there are 28 students in Mr. Miller's homeroom. How many ways can the students elect a student council representative? Alternate. So there's 28 total students, and we're picking one representative and one alternate, so that would be 2 people. So in my calculator, I would do 28p2, which is going to give me 756. All right, now we're going to talk about permutations with repetition. So how many different 10-letter arrangements are possible using the letters from the word automobile? So if you look at automobile, there is one letter that is repeated twice, okay? O is in the word automobile twice. So it's just talking about letters, so I'm not going to count O twice. I'm only going to count it once. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we're making, we put our total number, like how many it wants on top, over however many things are repeated. So O is repeated twice, so I'm going to put 2 factorial on the bottom. So that's going to give me 1,814,400. All right, number 11, how many different 9-letter arrangements are possible using the letters from the word disappear? So disappear, okay, we want a 9-letter arrangement, so we're going to put 9 factorial on top. And then we have to look at how many letters are repeating. So A is repeating twice, so I'm going to have 2 factorial on the bottom. And then also P is repeating twice, so I'm going to put 2 on the bottom. Okay, if it was repeating 3 times, I would have 3 factorial. It just depends on how many times the letter is being repeated. So that gives me 90,720. All right, then the last thing we're going to talk today is about a combination, and this is a group of objects in which order does not matter. And I'm going to give you the formula again, but remember, I put YouTube videos on Schoology so that you can see how to type it in the calculator a faster way. All right, so N still represents the number of objects available, and R is the number of objects being used for the arrangement. So the same thing that they meant with permutations. And then a shortcut is if you have the same number on both sides of C, your answer is going to be 1. All right, so let's look at 5 examples. Natalie has 16 close friends. How many ways can she choose 5 to be bridesmaids in her wedding? So her total number of friends is 16, and she's trying to choose 5 of them. So I'd have 16C5, which if I use the shortcut and type it in my calculator, I'm going to get 4,368. All right, 13, there are 24 students in Kyle's kindergarten class. How many ways can he choose 8 to attend his birthday party? So there's 24 total in the class, but he only wants to choose 8. So I'd have 24C8. And when I type that in, that gives me 735,471. All right, 14. Abby is adopting kittens from the pet store. If there are 18 kittens, how many ways can she choose 2? So I'd have 18C2, which gives me 153. All right, 15, there are 12 employees at a sub shop. How many ways can the manager choose for the Sunday evening shift? So N would be 12, R would be 4. So 12C4. And then lastly, number 16, there are 85 players on the football team. How many ways can the coach choose 3 to represent the team in a coin toss? So N is 85, and the coach is trying to choose 3. So 85C3, which gives me 98,778. So that concludes the notes on fundamental counting principle, factorials, and permutations and combinations. Again, make sure you watch the videos I've attached on the Schoology post to see how to type these things into the calculator.